This video illustrates the use of IGW to create a data-enabled model for the Kalamazoo River watershed in the state of Michigan. This model uses detailed existing datasets such as digital elevation models, bedrock elevation rasters, and hydraulic conductivity rasters from a massive statewide well database. The source of water to this model is the statewide groundwater recharge raster, and the sink in this model is the land surface, which acts as a drain. This model is generated with just one click and therefore uses pre-selected datasets by default. This preliminary model provides a powerful and useful framework which can easily be modified and improved upon by the user. To evaluate the model's performance, the model's predictions are compared to static water levels from the statewide wells database. The steps to create the model are as follows. 1. Launch the GIS Google Map interface. In the window that appears, click the toggle between Google Map and GIS icon to bring up the GIS interface. 3. Click on the Add New Modeling Layer icon to load the watershed boundary. Browse to the folder where the Michigan watershed boundaries are stored, and then load the WSH_big shapefile. 4. Zoom in to the Kalamazoo River watershed. 5. Select the WSH_big shapefile under Polygon Layers in the GIS Layer Explorer. Then click the Draw a Selection Box icon. Draw a small box within the Kalamazoo River watershed, and the entire watershed will be filled with red to indicate it is the selected polygon. 6. Click on the Data Enabled Modeling icon to create a preliminary model. A prompt will appear to clarify the datasets and key model features used to create the preliminary model. Select Yes to proceed. 7. Automatically, the watershed boundaries and data will be imported to IGW, and the workspace extent is determined by the watershed area. 8. Discretize the model using a slightly finer grid than would be provided with the default settings. 9. Edit the head display options. Enable zone color-filled head display. 10. Run the model. 11. Select the Domain Polygon in Attributes Explorer and then return to the GIS interface. Click on the Add New Modeling Layer icon to add wells from the statewide database. Proceed to See, MGMT Local Data, State LT, Categories, and then load the drift shapefile, which includes all recorded drift wells in Michigan. 12. Again, select the Large Watershed shapefile under Polygon Layers in the GIS Layer Explorer. Click on the Draw a Selection Box icon, then click within the watershed boundary. This effectively deselects the watershed polygon. Then, click once more within the Kalamazoo River watershed boundary and answer yes to the prompt that appears. This selects both the watershed and all of the drift wells within the watershed. 13. Click on the Data Explorer icon to import static water levels, or SWL, from the drift wells selected in the previous step. Ensure that SWL_ELEV is the selected parameter and that From GIS Importer is selected. Then click Import. Leave the Spatial Analysis window open and go to Utilities, Data Sampling, Show Model vs. OBS Sampling at WellLogic SWL from GIS Importer, then select Averaging in a Layer. A calibration plot showing the simulated head versus the measured static water levels will appear. Note the general agreement between the simulated and observed heads displayed in the plot. Also note that the RMS error, mean error, and Nash-Sutcliffe coefficient are displayed below the plot. Check the Add Confidence Interval box to show a 1 standard deviation line plotted above and below the line of perfect agreement between simulated and observed data. The confidence interval can be switched to display a 2 standard deviation line or a line based on a user-defined multiplicative factor of the standard deviation. The user can also add a band mean to the plot.